Good afternoon, students. I'm going to review two problems on your worksheet that were handed out today. I'm going to redo 15 that I put on the board. That way, if anybody's absent, they have this one and then do number 23 below it. So our goal here is to find this question mark, this angle down here. So I have to work my way backwards. If I need to find this angle, I got to first find this angle. But in order to find this angle here, I have to know this angle over here. In order to know this angle here, I'd have to know this angle here. And in order to know this angle here, I have to first know this angle here. So I can get this angle from this angle by the vertical angle theorem. So not only do I want you to put the angle in here, but I want you to write the justification. These are called justifications. You justify why you're able to do something. And we'll be using these in proofs. So I want you to practice getting used to doing them now so it'll be easier when you see them, when you write them in a two-column proof. So vertical angle theorem says that vertical angles are equal. So that's why it says vertical, and that's my angle symbol. By the way, I had somebody drawing triangles for an angle on their quiz. They obviously missed it all. Completely different, an angle symbol versus a triangle symbol. Okay, so now we know two of the three angles of a triangle. We know triangles add up to 180 degrees by the triangle. That's why this is a triangle, not an angle. Triangle sum theorem. TH always stands for theorem. So triangle sum theorem says the three angles of a triangle add to 180 degrees. Okay, so now I have 105 from 180 is 75 degrees. So now I have this one. Now I'm able to find this one by a straight angle theorem, or a straight angle. Straight angle adds 180 degrees. Remember, here we have a straight angle. Right here, a line. A line is a straight angle, 180 degrees. So 75 plus 68 plus x equals 180 degrees. And I solve that for x, and I get 37 degrees. So now I have this 37 degrees plus this 100 plus this missing one, and I have the triangle sum theorem again. So 37 plus 100 is 137 from 180 is 43 degrees. So that's how I got this one. And now I can finally get the angle I'm looking for because these two angles form a linear pair. Okay, linear pair, remember, means adjacent supplementary angles. They form a line. As we hear, it's only a pair. That's why we couldn't call this linear pair theorem, because there's three angles here. They form a straight line or a straight angle, which is 180. But when it's only two and they're adjacent, we call it a linear pair. That's the one you'll see on the park and on tests that they want to hear you know is it's a linear pair. So we know linear pairs are supplementary, which means they add to 180. So 43 plus x equals 180. Solve for x and you get 137 degrees. Now, if you notice, I said, or the exterior angle theorem. Remember in the angles video I taught you, we have an exterior angle here. This is an exterior angle to this triangle right here. Remember, if I extend any one side, the angle outside of it is called an exterior angle. And if you remember from the exterior angle theorem says the exterior angle equals the sum of the two remote interior angles, or we can call them the two opposite interior angles. Remember that vocab. Okay, that's going to come up more. We're going to practice more with the exterior angle theorem later on, but here's an example of it right now. So you notice 100 plus 37 is the 137 right there. So I could have got that way as well, or using the linear pair theorem. That's why I have either one here. Okay. You could have also thought of it as a straight angle, because again, that is a straight angle. So you could have done the 180 minus 43 there and got that as well. So really, you could have written straight angle like you did on this one as well. So you really have three different ways of doing it. Okay, but when it has just two adjacent ones, they want you to focus either on the linear pair theorem, or if it's with a triangle and they give you these other two over here, they might want you to focus on the exterior angle theorem. So just know that. All right, so there's 15 done for you. 23. Okay, we are wanting to find this angle. No, we're on solve for x is what we're trying to solve for. Okay, so I need to know these three angles right here. I know a triangle adds up to 180 degrees. Triangle sum theorem. Well, I was given this original angle right here, but can I get this one? Yes, I have a linear pair right here. That's why you see the linear pair theorem. That's my justification. That gives me 50 degrees. 130 plus 50 is 180 for linear pair. Adjacent, supplementary. They form a line. And then here, I can move this 8x plus 4 right into here. 8x plus 4 because of the vertical angle there, and these are vertical angles. So now I have all three angles right here inside my triangle, and then I add them all up, which is what I have written down here, equals 180 degrees. That's the triangle sum theorem. Now I combine like terms, just so you know. When I combine those like terms, that's actually a justification. We'll actually do justification with solving the equation as well. So that justification, and I'll type it in right here, right now is combine like terms. That's the justification to go from this step to this step. Then what did I do? Oops, let me move this right here. Let's make it a little bigger. Size-wise, let's go to 18. Okay, so we went from this step to this step by combining like terms. What did I do from here to this step? I subtracted 48 across. So that's called the subtraction property of equality. Okay, and you could write SUB for subtract, PROP, prop of, and you can write an equal sign actually if you wanted to. I'm just writing it out the first time here since you might not be used to seeing that. Okay, but I subtracted the 48 across, so that gave me this, and that's called a subtraction. Whatever I do to one side, do the other side, I subtract it from both sides. The reason we have to say of equality, because there's an equal sign here. Later on here in geometry sums, there's going to be a congruent sign right here instead of an equal sign. So you could have a subtraction property of congruence, but because these are equal signs, we say equality. That means equals. And lastly, what did I do from this step to this step? I divided by 11 on both sides, so that's called the division property of equality again because it's got an equal sign. Okay, so here are three more justifications now that you know these ones because I just introduced them to you that you will eventually use in a proof when you practice a proof with solving steps like this. Okay, you'll use these actual properties right here. Okay, so you're learning some of these justifications now. Okay, I'm going to introduce them slowly right now so that when you get to the proofs, you don't have to memorize so many of them because you're introduced to some of these already. Okay, and so that's two examples, two of the tougher examples on that worksheet right there. The others are simpler than this. As I pointed out in class earlier today, the only other justification that is used on any of the other problems on the first page that is not one of these is the word complementary. When you see that right angle symbol, you know you're going to be using complementary when the two adjacent angles add to 90 degrees. We know that's complementary. So that's the only one that wasn't used in this particular problem that could be used on any of the other ones. All right, and that ends these two examples. So now go ahead and make sure you finish that for next class. Also next class, just know I'm gonna be handing back those two packets, and we're gonna go through every single problem on those packets, and you're gonna take notes on anything you missed and any work you didn't show, so that you know from now on I'm taking this extra time at the beginning of the year to show you what I expect, so you do it right from now on. All right, see you next class.